Hello, Assalamualaikum. My name is Muhammad Farhan bin Adrus, and this is my group member Ashrik bin Kamaruddin and Hazri Ifan bin Muhammad Azman. This is our assignment for system protection. This is our journal, which is the analysis of voltage instability incident in the Greek power system. For voltage instability incident in the Greek power system, the July 1996 event. On 8 July 1996, four generating units feeding the 150 kV network in the southern part of the system with the total capacity of 580 megawatt were out of operation. The problem started at 9:45 am until 1 pm. During this period, the voltage of the 150 kV network in the Athens region fell approximately to 120 kilovolt, which is 0.8 per unit, while the voltage of the 400 kV network were near 0.83 pu per unit. The voltage level at the northern part of the system remained at the normal level. The voltage drop rates observed during the incident were 0.75 kV per 5 minutes from 9 am to 9:45 am, and then increased to 1.8 kilovolt per 5 minutes from 9:45 am to 10:30 am. The voltage drop was quite large for a relative small load increase. For a 20 megawatt load increase, the voltage drop was 2%, which is 3 kilovolt in the 150 kilovolt total. The figures show the line voltage at a 150 kV substation in the Athens region. Line 3 show the measure voltage during the incident, and line 1 and line 2 are simulation results. The voltage drop stopped at 12:30 pm when load of the 100 megawatt was disconnected in Athens and Thessaloniki area due to the triggering of the overload protection scheme of the interconnection line with former Yugoslavia. Even after the load shedding, the voltage remained at low level until the peak hour pass. Thank you.
My name is Muhammad Irfan. My matric number is B0820104038. I will continue the presenter, and my topic is the three type of component. The quasi-steady state QSS approach for voltage security assessment. During long-term simulation, different components are represented using specific equation. The first is short-term dynamic. Equilibrium equation are used to substitute the differential equation describing dynamic behavior such as generators, induction motor, and AVR. Long-term dynamic. Differential or different equation represent dynamic phenomena such as LTC, load tap changer, over-excitation limiters, and thermostatic loads. Then network representation. They use for algebraic equation describe the power system network. Then the QSS technique strike a balance between time simulation advantage and the efficiency of static methods. For the next slide is power system device and component contributing to voltage and stability problem are modeled in detail. First, magnetic saturation of synchronous generator. The second one is governor action and generation excitation limits. The third one is a VR drop of proportional controller. The last one is automatic generation control AGC. Then the QSS technique enable efficiency analysis of a large number of contingencies. For the next slide is advantage of QSS technique. Offer a compromise between time simulation and efficiency of static methods. Next, suitable for analyzing a large number of contingency and BEEI contingency situation. Last but not least, incorporate secondary voltage control if required. The last one is used in planning studies, load shedding, system design, and determining security limits. For the next slide is short-term voltage stability analysis extension. First, investigation of QSS method application to short-term voltage stability analysis aim to assess voltage stability in shorter time frame. Potential use in real-time monitoring and control of power system. Enable timely detection and mitigation of voltage instability issue. For the second component in WP step overview, developed at National Technical University of Athens (NTUA), focus on long-term simulation of power system, implement an equilibrium point computation program (EPCP) in each time step. Then solve a set of short-term equilibrium and network equation. Equilibrium point computation program (EPCP), how they use, how they generate, how they solve the problem. First, generalization of a conventional power flow program. Then, they utilize the reciprocity formulation for efficiency computation. Then, the next step is solve the short-term equilibrium and network equation. The last one is determine equilibrium condition of the power system. For the next step is reliability and application for WP step. WP step has been proved reliable in bulk power system study. Comparison with a full simulation program ETMSP show favorable result. Currently used by PPC, Public Power Corporation, for contingency evaluation, classification of countermeasure against voltage instability and collapse. Then for the next is introduction to S3 package developed at University of Leeds. Cover various aspects of voltage stability and security analysis. Utilize fast time domain simulation based on QSS, which is quasi steady state method. The key features for S3: fast time domain simulation for contingency evaluation and instability diagnosis, then sensitivity and edge vector analysis for identifying instability modes and remedial action. For the next is use is preventive mode, generation rescheduling, and corrective mode, load shedding. Last but not least is for implemented with three modules, which is QSS simulation engine, load flow program, and security limit set. Then the application of S3: planning study, consideration numerous long-term stability scenario and design load shedding scheme. Operational planning study, determine security limit, real-time environment integration in progress. That's all from.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ashif bin Kamruddin. My number matrix is B0820102001. So I'm going to present about the countermeasures and system upgrades. So for the measures taken by PPC to prevent future incidents, there will be short-term defense plan, mid and long-term action, measures taken for prevention, and further system reinforcement, and also future plans. So for the short-term defense plan, it will be increasing reference voltage set points of generators to 415 kV in the north and 420 kV in the west. Next, changing tap positions in EHV or HV substation in favor of the 400 kV network in the north central system. And also changing tap positions in EHV or HV substations in favor of the 150 kV network in the metropolitan area of Athens. And for the mid and long-term actions, there will be transmission network reinforcements, installation of new generating units in the Athens region, and installation of capacitors in the south part of the system. And measures taken for mid and long-term actions. Number one, introduction of a new 400 kV double circuit line connecting Athens to the central part of the system. Installation of a new combined cycle unit of nominal capacity 560 MW burning natural gas near Athens, feeding the 400 kV network. Conversion of an abandoned power plant in Piraeus to burn natural gas, now operating at a nominal capacity of 400 MW. Installation of new shunt capacitor banks of approximately 200 MVAR nominal reactive power in the south part of the system. And for the further system reinforcement, there will be upgrade of the connection between Peloponnese and the west of the system by adding two new 150 kilovolt submarine cables with a nominal capacity of 2 times 175 MVA. Number 2, upgrade of some lines in the 150 kilovolt network of Northern Peloponnese. And lastly, restructuring of the 150 kilovolt network in the west part of the system. So for the future plans for 2001 to 2000 to 2001, continued reinforcement of the system to ensure reliability and stability, and ongoing upgrades and improvements to meet future demand and prevent accidents.